for images or for text or for any kind of data?
Any kind of data. Like cryptography, we can send any type of data using
Okay,
cryptography.
tell me how it is different from watermarking.
Okay, wait a minute, sir. Wait a minute, ma'am. Sorry, ma'am. I have used two techniques in here: steganography and cryptography. And metamorphic cryptography is a combination of steganography and cryptography, because cryptography needs high security for transferring data from one source to another source.
Hiding
And in
message within another message.
yes, and steganography, in steganography we hide our data in any form.
Santosh, please mute yourself. Your presentation is over. Please mute yourself.
Can I continue, ma'am?
Yeah, sure.
Yes, ma'am. Ma'am, in steganography, we hide our secret information in the form of image, video, or text. And on the other hand, in cryptography, we share our information from one source to another source using key concept.
Okay.
These all are the different concepts. But
Okay, Neha.
when we combine both these approaches together, the metamorphic cryptography are born. This is called metamorphic cryptography, and our data become more secure as compared to cryptography and steganography. And this is the metamorphic
Thank you,
cryptography.
Neha. Thank you, Neha.
Okay, ma'am, but this is a block diagram of metamorphic
Yes,
cryptography.
yes.
It's
Thank
okay,
you.
Sneha. Sneha,
Okay,
please, uh,
okay,
please
okay.
complete your slides now.
Shall we go for next
Yeah.
presentation?
Yes, ma'am. The next paper ID is 57, Student Career Prediction Techniques Using Machine Learning, and the authors are Akansha Pandey and Dr. Alice Maurya. Akansha, are you present?
Yes, sir. Good afternoon, sir.
Good afternoon. Please share your screen and start your presentation. Akansha, is there any issue?
Yes, sir. Just a minute.
Okay.
Akansha, if you are not ready, we can call the next participant, I think.
Sorry, ma'am. Just system problems. That system is creating just problem. Just
Acha,
We
just a
can
minute.
we can get
you
back to
settle
you.
down. You settle down, okay?
Yes, ma'am. Yes, ma'am.
Yeah, paper ID 90, Performance Evaluation and Comparative Analysis of Machine Learning Models for Rice Yield Prediction. Author Ms. Kirat Kaur, Sandeep Kumar Singla, and Hanit Karwal. I think Kirat Kaur has joined here.
Yes, sir.
Okay, so I ask you to please start your presentation.
Okay, sir. Sir, my screen is visible.
Yes, it is opening.
Good afternoon to everyone present here. My topic is performance evaluation and comparative analysis of machine learning models for rice yield prediction. The abstract is in our use agriculture in the energy of the economic system and growth and extra than one Half of the population is dwelling at the agriculture output. Crop yield prediction will assist the farmers and different stakeholders for better crop planning, that is, promoting warehousing, marketplace costs, and so on. Various data mining methods and technique had been used in the past by various researchers. Still, a lot of research is going on in these fields towards, and researchers propose several strategies to increase the accuracy of crop yield for the crop yield. Introduction. Agriculture is practice of cultivating plants and livestock. Milestone in the history of human civilization due to agriculture man settled at particular place. Agricultural marketing sector is characterized by fragmented supply chain, huge harvest losses, lower yield and production, multiple market intermediaries, higher transaction cost, lack of awareness, and several other social economic factors are some of the acute problems being faced by Indian agriculture. These issues can be resolved using recent developments in the technology by the virtue of IT tools. Basically, in my work, I am using the machine learning algorithms. What is machine learning? Method of data analysis that automates analytical model building, branch of AI where systems can learn from data, identify patterns, and make decisions with minimal human intervention. Real-time data such as variety of seeds, climate, temperature, humidity, surface pressure, rainfall, etc. may be used as input to the machine learning model to gain more insights for agriculture applications like estimation of yield and production, logistic management, disease prediction, weather forecasting. Yield prediction is one of the challenging tasks and open problem in the agriculture. Plays an essential role in decision making at global, regional, and field levels based on soil, environmental, and crop parameters. Crop yield simulates help to understand the cumulative effects of water and nutrient, pest diseases, the impact of crop yield variability, and other field conditions over the growing season. Problem formulation. Crop yield prediction is an open problem in terms of accuracy and efficiency. Prediction of yield of crops should be accurate so that farmers come to know which type of resource is required to increase or decrease the yield. In-depth analysis of the historical and ground truth information. Selection of the crucial parameters for the yield estimation. These are some research papers which I have read. My main base paper is to explore the latest methods and resources for rice yield estimation based on KNN and linear algorithms, and also chooses to focus on data pre-processing and selection of parameters rather than just building the model. Objectives of my work is to generate dataset of from various sources after proper normalization, standardization, and pre-processing, machine learning model for the rice yield prediction, compare the results with different machine learning models. Methodology. First of all, data collection from various sources like online data from nasa.government website and yield data from the PAU, that is Punjab Agriculture University, and some data from the farmers by visiting the farms and with communication with farmers. Then data should be pre-processed. Then data should be separated in two parts, that is training. 80% data is in the training data and the 20% is in testing data. Then model development, prediction, and the output. Then compare the results between the two models. My implementation is by using the machine learning, which is the method of data analysis and automating creates the analysis model. It contains two types, that is supervised and non-supervised learning. Supervised is when we teach or train the machine learning data that is well labeled, which means some data is already tagged with the correct answer. And unsupervised learning is the training of a machine learning information that is neither classified nor labeled, not allowing the algorithm to act that information without guidance. My first data collection is from the nasa.government, from where I have collected the various parameters of data, that is average temperature, maximum temperature, minimum temperature, specific humidity, relative humidity, average rainfall, and the surface soil wetness. Next, my data collection is from the Agriculture University of Punjab. This data is in district wise data of yield prediction. This data is collected from the farmers. First is the time period of rice, which is grown in June, and the cutting of rice is in October. Parameters required for the crop, which is the main is temperature, rainfall, and the humidity. Second is the yield produced. In the last years, the yield is produced that is 28 or 30 per hectare. Type of soil is black soil and red soil, in which black soil is the best soil for to grow the rice. Type of rice grown, simple rice or basmati rice. Basmati rice is divided into two types, that is 1509 and 1121. Difference between basmati rice and simple rice: basmati rice need more water than the simple rice, and basmati rice take lesser time to grow than simple rice. Regression model which I have built, that is simple regression, tree model, and random forest. Uh, from these both, I have concluded the result that random forest is the best model to predict the rice yield. Uh, I have from the various parameters which I have collected, I have take the crucial parameters which is very important in the growth of rice and increase the yield production, that is the surface temperature and annual rainfall, which will increase the yield. By comparing these two models, the random forest gives the best accuracy. The conclusion: latest technologies provide some of the powerful system which helps farmers to take the best decision regarding their crop yield. There are some of the models which are used to predict the yield of the crop by taking average value from the previous year. To solve this problem, machine learning works on the historical data and the important parameters and gives the maximum accuracy. Agriculture is the energy of the economy system and growth. Crop yield prediction will assist the farmers and different stakeholders for better crop planning, that is, for promoting warehousing and marketplaces cost. Thank you.
Yeah, Kirat, you have not shown the accuracy. You are saying random forest is giving you the best result. Where's the result then?
Ma'am, from this random forestry, from this table and from simple
So
regression.
this table is showing me the surface temperature, annual rainfall, and rice yield prediction. But
Yes,
how do I know the okay, you are saying regression tree. In the case of regression, we used to measure the mean square error. Where is the error? This one is a supervised one. No?
yes, yes, ma'am.
And how you did the annotation in the case of supervised, as you are saying, you collected the data from the farmers.
Yes, ma'am.
So, in the case of data collection, who has annotated their data?
Sorry, ma'am.
Who has annotated your data? Supervised के case में we required annotated data.
Yes, ma'am.
So who did this annotation?
Sir, ma'am, I have combined the data of the data which I have get
It's
online.
okay. It's okay. It's okay. The data you downloaded online, you have the like predicted value, actual values available to you. But
Yes, ma'am.
the data you have taken from the farmers, for that actual data, how you find the actual data?
Ma'am, from the farmer, the data which I have collected from the farmers, their data I have noted down, and then their data, that data is
You
combined.
asked to the farmers
Yes, ma'am.
interviews. So how many farmers you meet?
Ma'am, 5 farmers, in
Five.
which there is one sarpanch in the field. From the 5 farmers, there is one sarpanch who I met.
Okay, this rice yield is dependent only on two features.
Basically the important parameters are these two. Basically the rice crop is the one crop which needs more and more water, but at the end when there is time to cutting, then there is not so much the amount of water.
Mm,
If
yes, yes,
sorry ma'am.
yes.
If there is so much of water while cutting, then it's it's time to, so that the yield prediction is very less. Sometimes if there is more and more water, the cracks are made in the surface of the soil, which will give the lower yield at the
Uh,
starting when we
It's okay. It's okay. The annual rainfall we can measure only once the year is completed. How the farmer will come to know that this year this much is annual rainfall is going to happen? It's difficult. We know it is raining heavily or it is raining light, but in millimeters, it's very difficult to know that how much rainfall is there in this particular year, isn't it?
yes ma'am.
कितने लोग mm में मापते हैं कि हाँ
मैम एक्चुअली फार्मर्स ने मेरे को एनुअल रेनफॉल का डेटा नहीं दिया, सिर्फ उन्होंने ये बताया कि हमें रेनफॉल या वाटर कितना चाहिए उस क्रॉप को ग्रो करने के लिए।
So
और
there are machine learning में there are categorical variable. You can add heavy, light or medium rain
यस मैम,
rather than going this numerical parameter. I think so. Think logically.
ओके मैम।
That's always from my side.
Bharat,
Next,
any query?
next.
Okay. Okay. I request all the remaining authors to kindly complete your presentation within 8 to 10 minutes. And next paper ID is 108, a smart job scheduling for latency management and in multi-layer fog cloud environment. And the authors are Upma Arora and Dr. Nipur Singh. Miss Upma Arora,
Yes, sir, I'm present.
please start your presentation.
Yeah, good afternoon, everyone. I'm just sharing my screen. Is my screen visible?
Yes.
Yeah, should I continue? Should I start?
Yeah, please go ahead.
Yeah, so the title of my paper is, of our paper is Smart Job Scheduling for Latency Management in Multi-Layer for Cloud Environment. Since the inception of cloud computing, various job scheduling algorithms are developed by the researchers for achieving multiple objectives in cloud-specific environments only. With the IoT and fog computing coming into being, the focus is now being diverted to develop and apply the existing as well as new scheduling algorithms that can optimize various parameters. The combined for cloud computing leverages the fair utilization of resources from both the edge and the core of the network infrastructure. Fog computing itself reduces the latency by performing some possible real-time processing at the nodes of the core, although in very specific latency-bound IoT applications, reducing latency further remains an all-time desirable goal to achieve. In this paper, we are introducing a new job scheduling algorithm that schedules the job tasks across multiple layers of fog cloud infrastructure. So, coming to the introduction, what is for cloud infrastructure? The vast amount of data generated from the various Internet of Things applications and management of such application has become major concern for the researchers. Cloud computing can manage these situations, but the distance between such applications and the cloud data centers create havoc when latency is concerned. For handling such scenarios where cloud alone cannot handle latency sensitive and real-time data analytics, the role of fog computing comes into the picture. Fog computing works in between the cloud computing and IoT application. So, working as an intermediary, it provides resource management, infrastructure monitoring, and data management. By it, I mean fog computing. Sensors and actuators provide additional monitoring components for IoT applications like healthcare and surveillance, etc. Thus, the combined system is called for cloud
गरम कर
infrastructure. Next is what is multi-layer for cloud environment? Multi-layer for cloud environment involves a framework where each layer focuses on the different aspects of the architecture. This has proven useful in its goal to reduce space, time, and computation overhead from cloud perspectives due to its traffic offloading and edge device proximity for computation. Next one is introduction to latency management in for cloud infrastructure. So what is latency? Latency is the time interval between the stimulation and the response, or more generally we can say a time delay between the cause and the effect of some physical changes in the system being observed. And there can be different parameters that cause the delay in the system, such as execution time, application loop delay, etc. So this is the review for the review of the relevant literature that is relevant to the topic of my area. So first one is, ma'am, should I continue with the review of relevant literature, or I should continue with the uh, next slides? Am I audible? Am I audible?
Yes, yes. Please go through your actual work that you have mentioned in your paper.
Yeah. So for that, I need to introduce the heterogeneity at different levels of cloud infrastructure, as I have introduced heterogeneity at different levels of this complete infrastructure. In homogeneous environment, all the resources and workload are of the same capacity. All the modules of the applications that are to be processed are of the same sizes and need the same capacity of computing resources. But in today's scenario, obviously this is not the wise approach. The size, RAM, MIPS, and bandwidth requirements of an application module can vary from one another. So the resources which cater to the need for processing the SAT modules also need to be made heterogeneous. And heterogeneity can be at different levels of for cloud infrastructure. First one is heterogeneous application modules. That means the sizes, RAM, MIPS, and bandwidth requirements of the application modules can be different from one another. Next one is heterogeneous fork devices. That means MIPS, RAM, and bandwidth requirement of different fork devices can be different from one another. Next one is heterogeneity of hosts. So, for my research, I have included all these level of heterogeneity at the same time. A single IoT applications on multi-layer for cloud infrastructure. A single IoT application consists of number of modules of various sizes. Apart from the module sizes, the RAM, MIPS, and bandwidth requirements of all the application modules can be different from one another. Considering heterogeneity while placing the application modules is of very much importance. And as I've said earlier,
सर सेशन खत्म
heterogeneity
होने वाला है बस एक ही प्रेजेंटेशन रह गई है
Heterogeneity at the level of fork device properties is just another aspect
Yes, sir.
to be considered while deploying the application modules on fork devices. The underlying architecture of fork computing allows to schedule the modules of an application in
जी
first
जी वो
come
मैं
first manner that fall in the route from edge to cloud. Though this serves the basic need of running application modules, latency-sensitive applications require the modules to be executed in even low times. We present heterogeneous shortest module first placement algorithm to be applied on application modules while simultaneously considering heterogeneity at different levels of for cloud architecture. So this one is the algorithm that we have introduced. Heterogeneous shortest module plus first. That means we have to place heterogeneous application modules on different devices of the combined for cloud architecture, which is again multi-layer architecture. So the input to our algorithm is modules list that will be consisting of different module sizes, MIPS, bandwidth requirement, etc. For cloud devices list, and output would be shortest sorted list, execution time, and total network users. So first one is the first step is we are going to define the module list, for device list, and processing elements. At the second step, we are going to add sensor and actuators to the system. At the third step, we are going to set up the latencies between different fog devices, fog or cloud devices layers, different layers of fog cloud devices. At the next step, we are going to calculate the total modules, which is going to be the size of the module list, and we are going to find an average module. At the next step, we are having a list which we are calling as sorted list, and we are not going to assign anything to it. We are going to create a null list. At the next step, we are going to create a loop from 1 to total number of modules, and we are going to ultimately find the smallest module by applying sorting algorithm. We are going to apply the sorting algorithm, and we are going to find the smallest module out of all these available modules using the temporary variable we are going to swap, and we are ultimately going to find the sorted list of modules. And then according to the sorted list, we are going to place these modules on the uh, combined for cloud system by comparing the elements in the list one by one to the average module, and by comparing this the MIPS of these modules in the sorted list with the MIPS available on the fog devices, currently available on the fog and cloud devices. And ultimately, we are going to find the execution time of each module and total network uses. So for the result purposes, what we have done is we have taken 5 configuration. For each 5 configuration, I need to tell that we have developed this model. We have executed this model on
You
a
will be
case
taking a
study.
subset of
Case study,
thousand vectors only.
which is
Now,
for
if there is no
which
structure
is for
in the code, then all these 1,000 vectors should
sorry,
be stored in the hardware during the communication,
let
and
me
it
stop
might
the
be
slide.
a costly thing.
Which is a camera surveillance application, and which is having 5 modules. And on this application itself, we
Objects and try to reduce that cost of saving the information. So we all know that if I take in place of f, if I take a finite field, then we know that f cube power n is basically a vector space, and it's a finite dimensional vector space. So when I take a subset of this f cube power n, which is a subspace, then we know subspaces have special structure. Okay, we can like easily describe the complete subspace using only finite set of elements. So rather than taking a random subset of f cube power n, we take a subset which is a subspace. So we call it as a linear code. Any general subset is called a code. Now, if that subset is a subspace, then we call it as a linear code. Okay, so this is from linear algebra. So a linear code, I mean, which is a subspace of f q to the power n. So we all know that every subspace is also a vector space, so it will have a basis. So that means rather than using the complete code C, we can just take a finite set of elements which are linearly independent and spanning the complete space just to represent the complete vector space. So here, rather than storing the complete code C, we just need to only look after those linearly independent vectors which generate the code C. So when you take all these vectors in a matrix, if every vector is taken as a row in a matrix, we call that matrix as generator matrix. If there are k vectors, then the rank of this matrix becomes k because they are linearly independent. So a matrix whose rank is k is can be taken as a generator matrix for linear code. So since we're talking it about over a finite field fk, and the k is the rank of the matrix G, then this code is C is going to have q to the power k code words. It's quite obvious, like straightforward thing. Okay, now if you want to send more messages, we need to have a large q or a large k. But the problem is for the large q, computations would be very difficult because large q means we are talking about arbitrary finite field, so it might not be applicable. So usually, as I said, in digital communication, q is taken to be 2. That means q is fixed. So if you want to send more messages, then we need to increase k. That means k should be taken sufficiently large. So this is all about encoding while communicating the information. At the decoding side, here I'm saying like this is all about I talked right now. conversion of X to G. So X is being multiplied with generator matrix G, and we convert a code. We find a code word C, and it will be sent to the channel. Now here, now Bob is at the receiver side. He will try to, from the received vector, he is trying to estimate whether or not there is an error. If there is an error, how to estimate that? So to address this problem, there is something called dual code has been introduced. Dual code will mean the orthogonal space of a linear space. So I hope you all know what is orthogonal space. This is set of all those vectors which are perpendicular or orthogonal to the vectors of the linear subspace C. Okay, so these are orthogonal space. We all know that every orthogonal space is also a subspace. So in terms of communication, we call this orthogonal space as dual code. Dual code is also a vector space, so it will have a basis. The basis of this set, the basis is basically, in terms of communication, we call it as generator matrix. The generator matrix of CPUB, okay, is called parity check matrix of C. Okay, now with respect to CPUB, it is called generator matrix. With respect to C, it is a parity check matrix. Now the relation between G and H is G into H transpose equal to 0. Why? Because every vector of G is perpendicular to the every column of H. It's quite clear. So G into H transpose equal to 0. Now, while you are encoding, if the X is the message intended to be communicated, you just multiply simply with K, because the length of X is K, okay, and G is of order K by N. So when you multiply these two, we get a row vector of length N. 1 cross N we get here. So it's a code word of length N. That means we're converting a vector of length K to a vector of length N. Now at the receiver side, he receives a vector of length N. He received now a vector of length N. Let's say C is the received vector. Now from C, he has to try to extract what the X was communicated. So for that, so he has to just simply multiply with H transpose. So if C into H transpose is equal to 0, that means the C is the valid code word, because all those code words are going to satisfy this relation, right? So we can replace this G by C here. C into H transpose equal to 0. So if C into H transpose equal to 0, then C is considered to be the valid code word, because it is orthogonal to all the code words of C, all the vectors of CPUB. So if it is not equal to 0, then you will identify that there is an error. So now to identify the error, there is another parameter used, which is called distance parameter. If the code words are at sufficiently large distance, then the decoding could be very easy. So if a code is having distance D, then it can correct D minus 1 by 2 errors. So actually, it's a floor of D minus 1 by 2. Okay, so if you want to correct more errors, then you should have more error correcting capability. That means D should be more. But you know, as I said, a K length vector is being converted to N length vector, then the actual information that you are sending per each bit of the code word is K by N only. It's obvious, right? Because we are intended to send K bits, but we are sending N bits. The actual information being communicated was K by N only. Now, so if you, because we are trying to add some redundancy, that means we are increasing K length to N length. So if you take large N, then rate becomes 0. That means the actual information that you are trying to communicate becomes very, very small. So you cannot have large N. That means we have to take small n only. But the small n doesn't mean that it is equivalent to K, because if it is equivalent to K, then there is no conversion of K length vector to N length vector. So we have to take a sufficiently small n. Now, if you look at these parameters, these are three things. There is a distance parameter, length parameter, and the dimension. So if you want to send more code words, we have to have K large. Here, large K is required. Okay. But in the second side, if I take large K, then rate is improved, but N becomes small. But we cannot, if you increase large K, then N should also be large. But if N is large, then rate becomes 0, I mean close to 0. So we have to have sufficiently small N, and also distance should be taken care. So this is an optimization problem. Now we cannot actually optimize three things. So we cannot, so we have to have the fundamental problem of coding theory is construct a code for a given two parameters. If your length, message length and code length is fixed, you try to find out the largest code whose minimum distance is good. Or else if you have a code with a sufficiently, design distance D with a given length, then what will be your message length you have to choose? This is a fundamental problem of coding theory. So in the literature, so many codes are proposed, and so many different families of codes have been introduced using finite fields. And recently, even researchers started using the finite rings in place of finite fields to study codes. Now, when you replace a finite field by a finite ring, then the ambient space is no longer a vector space, because we know that a vector space is talked over finite fields. But we are taking a finite ring now. So in case of finite ring, the things like R power n is not a vector space. So we don't have a generator matrix concept there. So we know that R power n is basically a module. So any subset that you take of Rn is called a linear code if it is an R submodule. So in case of finite field, we call it as a subspace. In case of rings, we call it a submodule. Now here the difficulty, I mean, in the first instance, it seems like, okay, what's the point here? Just a finite field is being replaced by a finite ring. So the moment you replace a field by ring, the completely setup is different, because in the ring, we have 0 devices. So it's going to create problem. So the first problem that we face is there is no generator matrix, because there is no basis which is going to span the complete module. Of course, there is something called minimal spanning set, that is set of minimal number of elements which can generate the entire space. So which we take the basis for C and do the encoding. So initially, when this was proposed in the literature, there were no applications. But in 1994, Hammond et al. Have proved that there is a very nice relation between the linear codes and non-linear codes over Z4. Suppose if I take any non-linear binary code, I hope non-linear is very clear, right? Because linear means it's a vector space. Non-linear means it's an arbitrary subset. So a arbitrary subset of F2 power n if I take, so this can be a linear code over Z4. So they have established the relation. Then this relation motivated the researchers to further study codes over finite rings. So now I'm going to talk about one special family of codes which are called linear complementary dual codes. So what do I mean by linear complementary dual code? So let's say C is a linear code, and we know CPUB is its dual. Now, since these two are sets, if I take the intersection of these two, so definitely there might be some non-empty intersection sometimes, but whenever the intersection is containing only 0 element, then we call it as linear complementary dual code. Linear complementary dual code means the intersection of a code with its dual is only all 0 vector. When C meets its C dual, trivially we call it as a linear complementary dual code. Now, when this property, like when the first instance, it seems like a mathematical property, okay? But in 2014 and 16, these authors have proved, Carrot et al. And Bringer et al. Have proved that these codes are very effective in side channel attacks and faulty injection attacks. Okay, in security, they are quite effective. So now, what is the so special about these codes? Why these are actually interested? Okay, so application security. What do I mean by side channel attacks is actually here when two persons are trying to speak, the third person was peeping to understand, like steal the information. He is trying to listen actually. When two people are peeping, usually the human curiosity is to trying to understand what the other people are talking. So when two computers are actually communicating, the adversary, the hacker is trying to steal the information. So this can happen in different scenarios. So one such scenario is by just analyzing the power that is consumed by an electrical device or the heat produced by an electrical device, and by analyzing its spectrum, one can easily try to extract the information which is being communicated over the electric device. This is one example of side channel attacks. Another example could be during the manufacturing of the electrical device, some additional components will be inserted such a way that the information which is being communicated through that device can be captured. So these are the two things which we call as side channel examples of side channel attacks. Now we do not know whether these things are actually happening or not during the communication, and when you are actually a user, you do not know whether there is some extra component inserted in the physical device or not. Even if someone is trying to listen, you do not know, but you have to keep your information securely. So to keep the information securely, here there is one idea proposed which is called masking. So what do I mean by masking? So in layman terms, masking we mean, for example, if you go to a medical store to purchase sanitary napkins, so what the shopkeeper usually does is he will try to wrap it in a white paper, some paper, and then put it in a plastic cover and give us. So he's actually trying to hide this thing that we are actually purchasing, product which are purchasing from the medical store. Okay, so this is an example of masking. So this is the information that we want to send. Okay, so if it is directly sent, then anyone can see, right? So just to protect that, what he is trying to do, he just wrapping it in a white paper and putting it in black cover. So this is the idea that we're going to use to address the side channel attack problem. So let's say X is the information that we intended to communicate. That means it's with the layman example, if I compare, it's like a one piece of sanitary napkin. Okay, now we what the shopkeeper does, he will try to mask it with white paper. So white paper is basically a code here. Let's say C is a code of length n whose generator matrix is G. This is the linear code that we're taking. So now we know how to convert this to a code word. So just multiply X with G, we get code word. That means it's a complete pack of this sanitary napkins. Now here he will try to do the masking. He will wrap it with the paper. So that paper is basically a random vector Y. We take a random vector Y and wrap it with this. That means actually XG is the information that we want to communicate. Now if we communicate XG directly, so what attacker tries to do is to compute this XG, some power is being consumed by the electrical device, or some heat will be produced during the computation of this XG value. He will try to extract that heat produced or the power consumed, and he will analyze that information and try to find out what X is being computed. So just to confuse him, what we do is rather than compute XG, we compute XG plus YH now. So if you compute XG plus YH, even if he does the power analysis or the heat analysis, he will only get to know about the power that is being consumed for Z, but not for X. Okay, so we are trying to confuse him here. Now the question is at the receiver side, now the receiver Bob receives Z, not XG, because in earlier case we were sending XG directly. So he will try to find out X from G, X from XG. But here now, rather than sending X, just to create confusion to the attacker, we are sending XG plus YH. Well, this might create a problem to the Bob. So because he should be knowing how to extract X from this XG plus YH. So here, how it is computed? So just multiply this Z is equal to XG plus YH with G transpose and H transpose respectively. When I multiply this with G transpose, I get this vector. And when I multiply with H transpose, I get this vector. So how do I get this? Because when I multiply this expression with G transpose, here I get X into GG transpose, plus we have Y into HG transpose. We know the relation between G and H, no? G into H transpose equals 0. Therefore, this second term becomes 0. So when I multiply with H transpose, the first term becomes 0. So here XG transpose is XGG dash, and Z H transpose equal to Y H transpose. Now, somehow, if I know that if you are somehow able to find out the inverse of this matrix X is G transpose, here you can find out X, right? Because X can be written as Z G transpose into G transpose whole inverse. So now this is possible only when the matrix G into G transpose is invertible. Now what is G, by the way? G is the generator matrix of the linear code. So if you take the transpose of this matrix and multiply with it, we get a matrix G transpose. So if the G transpose is invertible, then Bob can extract the information that is X from XG plus YH. Otherwise, it is not possible. Now, when you take a random linear code, for a general random linear code, G into G transpose might not be invertible. Okay, so this is where the LCD codes are playing major role. So if I have a linear code, I mean LCD code, its matrix, generator matrix into its transpose will be invertible. So this is the idea proved in 1994 by Messe. Similarly, even in faulty injection attacks, this can be used. Due to the time, I'm just skipping this slide. So what is the basic idea here is how to construct LCD codes, okay, with a better minimum distance. So recently we have constructed, this is our work. So this is the idea of how LCD codes are being used. So we have constructed LCD codes over a finite local ring. In the literature, there are codes available for fields. Now we replaced fields by rings. As I said, like this is not straightforward. So we just proved that if you construct any LCD code over a local ring, it will always be free code. So what do we mean by free code is, for every LCD code if we have, you'll have a linearly independent set of vectors which generate the complete space. That means you cannot have any non-free linear code. That's what we proved here. So, and even for the finite rings case, this result holds. That means if I construct a linear code with generator matrix G, which is LCD, then G into G transpose is non-singular, means it is invertible, not just for finite fields, it even still works with rings. Now, this motivated us to construct good linear codes, and we did. I mean, at the end, I'm going. So this paper, in this paper, there were so many results which are talking about the distance and other things. So this is all about how LCD codes are used in security, and there are further applications which are in private information retrieval, even in secret sharing, even in entangled assessment, quantum error cutting codes, even in distributed storage. So if Okay, I'll be stopping here because I think I'm running out of time. So these are the sum of references I just used. So this is the talk is mainly based on this paper, which is do non-free linear codes exist over finite journeys. The other two things that were used are this. This is about how one can even protect the information in side channel attacks using LCD codes, and the basic paper for LCD codes. Yeah, thank you.
Thank you so much, sir, for
Yeah.
sharing your valuable knowledge with us and such a nice presentation. Thank you, sir. I hope it will be beneficial for our research students and faculty members. Thank you, sir.
So, if I have any questions, I can, if you have time.
Anyone want to ask any question? I think no questions, sir.
Okay, thank you. Yes,
Okay, sir.
thank you so much.
Thank you, sir, for joining
Thank
us.
you.
Thank you.
Thank you so much.
Our next speaker is Professor Bonia Ebenzer, who is an adjunct professor in the Department of Mathematics, Universitas Erlangga Faculty of Science and Technology, Indonesia, and he is also working as senior lecturer at Akenton Appiah Menka University of Skills Training and Entrepreneurial Development. He has completed his PhD for Kwame Nkrumah University of Science and Technology, Kumasi, Ghana in 2014, and postdoctoral research fellowship from Wal University of Technology, South Africa. His area of specialization are mathematical biology, mathematical modeling, spatial analysis, fractional calculus, and mathematics education. He has taught various courses in undergraduate and postgraduate level like psychology of learning mathematics, abstract algebra, modeling and problem solving, teaching and learning and assessment strategies in mathematics education, and many more. He has published more than 90 research articles in peer-reviewed journals. He has written 3 books related to mathematical modeling and fractional operator and its applications. He has also delivered talk in various conferences and seminars around the globe. He is reviewer of many reputed international journals like Biosystem Elsevier, Applied Mathematics and Computation Elsevier. He is editorial board member of many national and international journals. He is a member of International Association of Engineers, Hong Kong, and Mathematics Association of Ghana. He was awarded certificate on top downloaded paper in the Journal of Optimal Control Application and Method in 2018-19. So I invite Professor Bonia Ebenzer for his presentation. यहाँ से
I would like to share with you a little bit that has been applied on coronavirus, which disease. as a keynote speaker.
यहाँ से उठाइए मैंने
So, so this is going to be my outline of my talk. Talk a bit about introduction, definition, application of corona. let us see the implementation of it. So I can generalize the exponential function to go what you call the Luther law or Luther function, which has become one of the most popular operators, popular applied operators. So the fractional order group is more similar and allows to describe two different waiting types. Distribution is ideal type. Distribution is such as observed is what nuclear magnetization. Then the over behavior of both operators is due to the capacity not obeying the classical index of composed by just normal fractional calculus. So the tail of the calculus can stretch from one operator to one another, and therefore helping to predict accurately. So I gave the following definition that would be applied for the proofs of the existence, uniqueness, and position of capital. So this is the definition. I'm showing the definition assuming that the age of here NY2 where NY greater than to the functional the CF operator is given by this definition. Then we say again that where M of B using the normality that certify this condition of not is equal to M of 1 is equal to 1. The integral operator corresponds to CF fractional derivative for lambda modified and also implicit changes definition. So based on that, a comorbidity model proposed by myself was rationalized, in other words, using capital operator to examine this model. So in the model, then the CH, the C suffix M, I suffix C, V, R suffix C, V, I suffix V, M, R suffix have been properly defined here. Why I call here susceptible woman, comorbidity susceptible woman, woman infected with COVID-19, woman recovered from COVID-19, woman co-infected with mobility and coronavirus, woman recovered from comorbidity disease. So this is exactly what you saw in the model shown previously. So then we look at what we call the statistics. So this is the free equilibrium. This is endemic equilibrium solution that are obtained. Then this is a reproductive number. This is telling you how many people can infected person infecting the Belgian population. I have to calculate that because very important threshold in disease modeling, which I did. So because I'm doing fractional perspective, it's also important indeed to look at if there's an existing any kind of solution of my model. So in this regard, that also examine, I don't bother my audience with this jargon of computation. So I just say here that the fixed point theory in pure math was employed to establish existence uniqueness solution of the proposed model. So initially, the model is reformulated in terms of global derivative. And the following is obtained to consider the fractional order. So in other words, here, trying to impose what you call stochastic component in the model that was shown earlier. I want to see with time factor, which is it appears that in modeling, we say that the classical differential equation, saying that the time is linear. Is that so? It's not so because disease incident can increase and decrease depending on the condition in a given time. So I wanted to see how stochastically this can influence the dynamics of the model. So therefore, stochastic component is introduced. I introduce stochastic components, then try to look at it. So this is stochastic component introduced. Okay. where I've defined what all this means within the original model is here. Then I just show you the numerical scheme that adopted for this, which was proposed by Akangana and SIDA. The SIDA is one of the new researchers from Sheikh University in Tech. Is also my friend. So we numerically examine the model in this context in these respective variables, numerical schemes. I hope you can see. Okay, I hope you can see. So we use but Fox scheme which framed in the context by Atangana and Sida. These parameter values are shown here. So obtain these results, not with stochastic. So let our ask audience how you see this. So this is the insatiable and the rest. So yes, I'm more interested in this one. So this one will impose stochastic component in the model. So you see that there's fluctuations in the dynamics. And this is what in real life likely to happen in the disease modeling perspective. Why am I saying this? Because look at corona dynamics. Today, the disease can be contained if factors that have the disease to increase happen or become the order of the day. What happened? It triggers, and you see higher incident. So this is what happened, and it's going to be compared. This is the determinate fractional derivative with the same CF recruiter. This is where I impose the stochastic component to see that we have that base fluctuations. This is a reality for me what happened in the normal red time as far as the dynamics of the disease is concerned. So I would like to conclude by saying that I've examined the dynamic of comorbidity. The steady state of the model has been established with relative number also determined exponential law was applied to study the dynamics of coronavirus community by establishing the distance and uniqueness of the solution of the model using fixed-point theory, which I've explained. Then a stochastic approach was also employed numerically. And we show you the difference between the two graphs by showing the fluctuations in the dynamics and I'm showing linear perspective. We say that the numerical solution is also just that the fractional order derivative and parameter value have serious impact on the dynamics and fractional linear values. Why are you saying that? Because if I forget the parameter, I get to get different solutions. Similar results were obtained for stochastic. There was some except that the stochastic dynamics we saw fluctuations. The fractional stochastic numerical really shows that the random nature of the infection is not fixed. This can help our medical practitioners to take the right decision when we are, making policies regarding the disease. This is very important. Very important as researchers. So that ends the first part of my presentation. These are some of the references that were considered for this part. Now, again, if you look at what I said I was going to do, I said I have two talks. The second talk has to do with protection. You all know that protection is one of the most utilized disease, utilized tools, across the globe. Every continent lives well, they use potato, either the raw potato or a processed form of potato or one form of carrot. He said that potato is a starting rich food originated from East of South America. Today, potato-related foods are identified every continent using technology. If you come to my country, Ghana, where eat KSCF, other foreign food bank, vendors or shops, you find process to get food stuff around. So this is important crop and is vulnerable to a number of diseases, including viral one, what is more dangerous to survive, to the survival of the crop. The disease accounts for about 50% of the global loss of potato yield. The disease is found in all parts of the world where potato doesn't survive. So this calls a serious investigation. That was my passion to study the disease around potato. But this model has been examined classically by an author. I felt that there was still a gap to look at it in a closer more using fractional perspective. Why am I saying fractional? When you take into consideration memory effect, what happened in the past, what is happening in the present. I believe that the results of my study is more or less better than what is done in the classical domain. So the total potato population at the time T is subdivided into soluble potato, exposed potato, infected potato, the total vector population petition to soluble potato, and infected potato. In fact, this is the model that will derive out of the interactions that I've just explained. And all the parameters are same parameters that came from the original paper. So because of presentation, I'm not going to bother my audience with the name and date parameters. I'll share in the later during the ask question that I can share. So here, I think I've talked about susceptible potatoes, exposed potato, infected potato. This is susceptible vector, infected vector. These are the compartments. So due to this compartment and the various interaction among the compartments, resulted the following differentiation. This is the initial condition, right? So what I mean by what we've done, look at the disease-free equilibrium, the endemic equilibrium has been studied in the work. What I really show the actual one, but I've seen that has been done. But I look at the local stability of the disease-free equilibrium, I didn't do the endemic. Why? Because my more interest was to establish the uniqueness of the system oscillation, which will cater for the global perspective. So I studied resistance and nuclear by using analysis. Even when people can harvest urban stability approximation, that technique that I've used, whether it stands the test of time, which I did, and I was able to prove that there's that stability for that estimation techniques that I'm using to establish my uniqueness in resistance solution. So this is what happened. My focus numerically in this work is not the classical, numerical separation. So I impose on stochastic components. And these are the stochastic aspects. The theta1, the x1 here. So what I've defined the x of the 1 according to the standard Brownian motion. Why theta of the 1 degree is stochastic constant. So this is the stochastic component that are imposed on the original model. In fact, I didn't also here also use the numerical schema that imposed by Tangana and Sida again. I thank them using the numerical scheme that we have proposed, which I use. Then based on that, you obtain this classical solution as usual first without imposing the stochastic components. This solution will obtain. And I went further now impose my stochastic components. So this also telling me the actual dynamics that is not linear. if anything happening in each component or the variables in the model is being dictated by this random effect. Go up, go down, dependent dynamics of the disease at the time. So we conclude by saying that the local stability was carried out, which was found asymptotically stable. The study established existing uniqueness of the solution of the protective mode using balanced space approach. However, alarm stability that was carried out to determine the robust nature of the ABC of the existing uniqueness of the solution of the model. Then a stochastic component included in the ABC model numerically solved. We saw that the two numerical solutions obtained with or without we show that the one with the stochastic is depicting the variations of the stochastic effects. And that is very, very important. So I want to summarize my talks that I can assure you fractional capital has a future and is the way to go, whether you like it or not. Be it BD, any differential equation you can embed that in fractional perspective. And I can say for a fact that in the biological processes cancer modeling, in any serious biological cells mutilation and others, now researchers are embedded. So I'm concluding by telling organizers or informing organizers or by just giving my overview that you've done well, very appreciative. On behalf of the people of Ghana, my Vice Chancellor, the Department of Mathematics Education of Arkansas, University of Skills Training Complementary, I am extremely grateful for this opportunity. Thank you.
Thank you so much, sir, for such a wonderful presentation. I hope that the knowledge you shared with us will help immensely. Thank you, participants, for joining us. Now, I would like to ask for Dr. Kamlein sir for proposed vote of thanks to our speakers.
Thank you, madam. First of all, I am very thankful to Dr. Ramakrishnan Bandi sir for accepting our invitation with very short notice. Thank you, sir, for your nice presentation. I hope the research fraternity of mathematics and computer science both benefited from your talk because your lecture on LCD codes and their application in security and privacy cover both the area mathematics and computer science engineering. I am also thankful to Professor Bonia Ebenezer sir. He explained the origin and history of different kind of fractional derivative and its importance. He also discussed the stochastic coronavirus model with comorbidity and discussed the numerical scheme for coronavirus with comorbidity model. He also discussed the fractional dynamics of a potato disease model. I am again thankful to all of you. Thank you.
Thank you all. Now I request you all to join next technical session 2 at sharp 3:10. Thank you so much. And link is given in the schedule. Thank you so much.